Hello, Valley Montessori School, and anyone else who has stopped by. This little video is a follow-up to a presentation that I gave to your school in September about the sun. I told you then that I would be sailing with a cruise ship up and down the coast of Norway for a couple of weeks. And one of the coolest things that we got to see was the Northern Lights. So I'm going to talk to you a little bit about how the Northern Lights work. Now, you may not actually know what the Northern Lights are. They also go by the name Aurora Borealis, and in the Southern Hemisphere, they go by the name Aurora Australis, or Southern Lights. But these are wispy little green and pink and red lights that happen near the poles of the Earth. But why do these lights actually happen? Well, it may surprise you to find out that these lights happen as a result of what the sun is doing. Now, I'm going to show you a video by NASA that helps us understand where the Northern Lights come from. Northern Lights happen because the sun is always throwing particles at us, and sometimes they throw quite a bit more particles at us because of extra magnetic energy on the sun, which we can see in these dark spots here. Now, when those sun particles hit the Earth, sometimes they hit us so hard that they actually peel back Earth's own magnetic field. And then they start to squeeze our magnetic field together on the far side of the Earth here. You see these field lines coming together? And when they reconnect, they transfer a ton of extra energy to those particles, which then spiral down the field lines and start interacting with things in our own atmosphere, causing the emission of light. That's basically what Northern Lights and Southern Lights are. So why do we see that kind of light at all? Well, it's because the particles from the sun have a lot of energy, especially after the connection of the magnetic field. And when they come down to the atmosphere, they donate their energy to particles that live in our atmosphere, such that those particles are excited. Now, everything that goes up has to come down. So when those particles de-excite, they actually release more energy in the form of light. And the color of the light depends on the amount of energy that they absorb in the first place. It depends on what kind of particle it is, and it depends on where that particle lives in the atmosphere. So when we see Northern Lights, the most common color that we see is this green here. The green comes from sun particles hitting first a nitrogen atom and then an oxygen atom, which glows green. And that happens at about 100 kilometers to 200 kilometers up in the air. But green is not the only color that a northern light can have. If the sun particles hit an oxygen atom that lives higher in the atmosphere, higher than 200 kilometers, then that oxygen, as it de-excites, will glow red. A similar thing happens below 100 kilometers. If a sun particle hits what's called molecular nitrogen, so two little nitrogens stuck together, then when that de-excites, it will glow pink. So how do we know whether or not we're likely to get northern lights in a particular night? Well, it turns out that there are lots of people that are always watching what we call the space weather to try and predict whether or not we will have northern lights. One of these organizations is called the Space Weather Prediction Center, and you can learn more about them here. What they do is they constantly watch the sun to see if the sun is throwing extra magnetic energy at us. They watch to see whether or not the sun has sent out a big magnetic explosion, and then they use that information to try and predict where the northern lights can be seen on the Earth. This picture is a picture of the Earth looking top down, and the green is what we call the auroral oval. It's the places on Earth that surround the North Poles that are most likely to see northern lights for a particular day. Now, we were really lucky on our ship because we sailed all along the coast of Norway until we got up here to a town called Alta. And from there, we could drive south to this place here, which was located right in the middle of the auroral oval. So we knew that we were pretty likely to see northern lights once we got up there. And as it turned out, the prediction was right. We had a really lovely northern lights show for a couple of hours when we were outside. It was really, really cold, but it was totally worth it. And you can see this big arc here of green light. And then here you can see several different arcs. You can see that green, which we learned is both atomic nitrogen and oxygen. But you can also see this red glow here. That's the top of an arc that's in the back there. So we know that this is high altitude atomic oxygen. Now, northern lights can be a little bit deceiving when we look at them with pictures. This is something that my camera captured after about a 20-second exposure on my phone camera. But this is closer to what my eyes actually saw. That's because cameras and eyes work completely differently. Eyes have two types of cells inside called rods and cones. And when it's dark outside, our rod cells take over. And basically what they do is they wipe out all of the colors to almost black and white in order to enhance our perception of contrast. Because contrast is a lot more important for us to get around in the dark than color. Cameras, on the other hand, are able to store both light and color and stack them all together into one very bright, vibrant image like this one. So where you may see this kind of thing in reality, your camera can pick up a lot more of the color information. But either way, I was really glad to have seen them. I'm looking forward to my next trip up north with them, and I'm really glad that you joined me today. I hope you're able to join us sometime in northern Norway and see the northern lights yourself. Have a wonderful winter break, and I hope to see you soon. Bye!